Kubernetes layer. So all of those integration and all of those challenges has been removed by introducing a purpose-built operating system based on Red Hat Enterprise Linux. And also you get access to the Kubernetes engine, which is again, it's not just the bare metal Kubernetes, you have all the features, functionalities surrounding it. And also you have access to what we call the UBI, Universal Base Image, where you can use that as your base container image. You layer your application code on top of it, and you can create a container and deploy it. So it is more beneficial than as a customer or as a partner, you going and downloading certain images from a third-party repository and using that as your image base. With Red Hat, you get that trusted container UBI images, which you can use it right away. When I say comprehensive platform, it involves monitoring, logging, the inbuilt registries, even CI/CD tooling, which is again inbuilt capability as well. So as a customer, you have an choice or flexibility whether you want to use external one. Yes, you can use it, but all of these features are readily available for you from day one. So the soon as you deploy OpenShift platform, all of these features, functionalities is available for you. So you can start using right away. And if I have to just compare this with any of the cloud provider offerings, so what is the difference? If you want to deploy, for example, any XKS offering on any of the cloud, so you need to start from the underlying operating system. The underlying operating system varies from cloud providers to cloud providers. And also you have to integrate different monitoring services, CI/CD services, registry, service mesh, all of those key components you have to integrate. You have to use the existing services provided by the providers, and you have to integrate them. With OpenShift, you don't need to do any of those additional tasks, which is already available, which is readily available within single console. You can start using that right away. And with that, what you get is a consistent experience across cloud providers. So your developers will use the same tooling everywhere, whether it's on-prem or cloud, and they have access to the same self-service portal. Same thing goes for your operations team as well, where they maintain the OpenShift cluster same way as on-prem. The same operational procedures applies for cloud environment as well. They don't need to learn different how to manage different cloud providers or how to use different cloud services, etc. So it's the same experience everywhere. And with that, what we provide to you as partner or customer is the choice and flexibility. You are not locked into any specific providers. So you can choose which provider you want to deploy it on. For example, you want to deploy it on Dell environment, you can do that as well. Or you want to deploy it on Azure or AWS, you can deploy OpenShift there as well. So as a partner, you have a choice, flexibility to deploy your applications anywhere. This is just an example to make it easier how to understand how OpenShift differs from the other offerings. If you think of Kubernetes, it is just the engine. To build a Kubernetes platform where you can run it in production, you need to actually build a car. So you need a lot of other parts. In cloud providers, as I said, it is different services which you have to integrate them to build that platform. So from as a partner, what's your objective? Whether it's building the platform or you just want to run your application on top of it. So what OpenShift provides is an opinionated platform where it's like a already built car, which is readily available for you to drive. So you don't need to do any additional work. And the next step of that is, okay, if you're saying, I don't want to manage the maintenance of the car, or I don't want to keep managing the environment, Red Hat, you manage it for me. So that's where the managed services comes into picture. So we work with cloud providers like AWS and Azure to provide a fully managed service. So as a customer or a partner, you can just focus on your application and leave the underlying infrastructure operations to relevant cloud providers and Red Hat. So this is a high-level overview of what OpenShift environment, what are the components of OpenShift. So OpenShift, as I said, it is built on Red Hat Enterprise Linux. CoreOS is the purpose-built OS for OpenShift. And then on top of that, we have the upstream Kubernetes and then we have the cluster services, which includes the logging, monitoring, registry, authorization. Even you can run virtual machines on top of this Kubernetes environment. And these offerings is called Red Hat Kubernetes Engine. And the next level of offering, which is Red Hat OpenShift Container Platform, it provides additional capabilities like platform services, application services, data services, and developer services, which includes, again, service mesh, log management, cost management, API, integration messaging, even data analytics. You can run your AI, ML workloads on top of OpenShift. And also we have integration with NVIDIA and other hardware accelerators so that you can access the GPUs for your AI/ML workloads through OpenShift. And developers will have access to their favorite IDEs, CLIs, and they can use their own runtimes as well. So this is the default offering for many of the customers. They are starting with OpenShift Container Platform. And the next level of offering is OpenShift Platform Plus. What it does is, if you are a partner who is running multiple clusters for your customers, what you can do is, using advanced cluster management, you will have a single pane of glass view where you can manage, maintain, do the lifecycle management of those multiple clusters. That's off. That's part of OpenShift Platform Plus. Then we have advanced cluster security, which again provides enhanced security in terms of vulnerability management, scanning, threat detections, and all of those features. And if you want to build your own private registry for your internal use, you can use Red Hat Quay, which is again a registry service from Red Hat. And also, if you want to use uh, persistent storage for your applications, then you can use OpenShift Data Foundation, again, which is part of OpenShift Platform Plus offering. So as a customer, you will have three options to choose from. And by default, many of the customers are choosing OpenShift Container Platform. And if you have multiple clusters and you need advanced features, then you can start with OpenShift Platform Plus. I'll I'll just pause here. Any questions in the chat? I cannot see the chat.
Anish, currently there are no questions in the chat.
Okay. Yep. I talked about ISV ecosystem. So by default, you can utilize the features functionalities provided by OpenShift. Also, if you are working with the existing ISVs and you are using their software, you can onboard those software on top of OpenShift as well. For example, if you want to uh, use Dynatrace or New Relic for management, or for example, from infrastructure layer itself, if you want to run it on Dell hardware, you can do that as well. And even from platform services, you have a choice of what you can use. So what these ISVs, they have tested their products to run on OpenShift. And also they have created something called operators. Operators are nothing but a way of deploying applications in an easier way. So what you can do is, from console itself, you can select few options and you can deploy it. So you don't need to worry about setting up, deploying, installing all of those like applications. So you can just deploy an operator and the operator will takes care of that installation configuration part. Okay, so finally, in terms of benefit, what customers or partners get out of this OpenShift platform, right? From management perspective, it is time to market and efficiency within the teams. So it drastically reduces the time required for developers and operations team to build and deploy an application. And specifically from a developer perspective, they get to choose what kind of tooling they want to use, and also they have option to choose what kind of a runtime they want to choose as well, programming knowledge, programming tools as well. From operational side, they have the same experience. How they are maintaining that environment on-prem is the same way they're going to maintain it in cloud environment as well. And with OpenShift, we provide something called IPI installation, installer provision infrastructure. So when you just run that OpenShift install script, it goes and talks to the infrastructure provider. For example, if it's a Dell hardware, it talks to that controller, or a VM where it goes and talks to that vCenter and then deploys all relevant components required for the OpenShift installation. So installer takes care of everything. And if you want to do a customized install, then we have something called UPI, user provisioned infrastructure, where you can customize the OpenShift environment as per your requirement. So essentially, from an infrastructure benefit point of view, you will reduce the infrastructure footprint, and I will cover on how you deploy this OpenShift across different infrastructure footprints, whether it is from data center till the remote edge as well. Okay, so let me quickly take you through the OpenShift architecture on a high level. What components are part of this OpenShift? So it all starts with the underlying infrastructure, whether it's compute, network, and storage. Again, has Dell Technologies. They have done their testing, validation to run OpenShift on their server hardware and even storage infrastructure, etc. So you can use that as a base. And then you can deploy what we call the master nodes. Master nodes, also called as controllers. So essentially, these are the nodes where all the management services will run. The services, the management controllers, and pods will run. And the key component of that management node is what we call HCD database. You can think HCD database as the brain of the cluster. So it stores all the information about the cluster, the state of the cluster, whether how many users logged in, which pods are running on which nodes, the state of the controllers, everything is stored in HCD database. Then we have a node type called worker nodes, also called compute nodes. So this is where your application is going to run. Whatever the applications you are deploying, it will be deployed on these worker nodes. And when it comes to OpenShift subscription, you need OpenShift subscription only for these worker nodes. For example, if you are deploying worker nodes on a virtual environment, you just count the number of vCPU on that particular worker nodes. And if you are deploying it in a bare metal, you just count the sockets on that particular bare metal server. So each 4 vCPU equals one subscription, and each 2 socket and a bare metal equals 1 subscription. So that's how easy it is to calculate the subscription needed. Okay, coming back to the management plane, where the master nodes also runs a few other services. One of them is called scheduler. A scheduler is a service which manages how pods are placed in a cluster. So it checks the worker nodes whether resources are available in worker nodes or not. So accordingly, it will place the pods onto those different worker nodes. Then we have API server. So this is the service which interacts with all other components, essentially handholds or handshakes between different components. And it also the service which cluster, it tells the cluster to do things. So in terms of services, interacting with the different controllers, deployment controllers, etc. Then we have cluster management, which essentially what it does is it manages the health of the cluster, whether it is the replication node, the worker nodes, the services, etc. It manages all of that. And Kubelet is the key service which runs on the worker nodes. If you imagine worker node as a ship, and you can think Kubelet as the captain of that ship. So it essentially manages whole aspect of what happens within that particular worker node. It also checks the health of pods running on that particular node, and also interacts with the Kube API server to share or exchange information on what's happening on that particular worker node. So how it all works together. So we have all these key services across master or controller node and worker nodes. And then when we deploy our applications onto these worker nodes, this deployed in something called pods. Pods is an abstraction layer outside of container, and how these pods will interact with each other. So that's interaction is happens via service happens through service, so which essentially manages and maintains the internal communications. So how we now we want to expose this application to external world, or we want to access it through internet. How we are going to do that? So that's where the route comes into picture. So when we attach a route to this service, you can access that particular application through the internet or from external world. That's on a high level. I know it's very short, but that's on a very high level on how OpenShift architecture works. When it comes to deployment models, you have a choice and flexibility on how you can deploy OpenShift. For example, you have a main data center where you have enough resources. You can deploy it in a proper way with three controllers and three worker nodes. And also you have an option to add infrastructure nodes. In some cases, what infrastructure node does is it offloads certain services from the controller node into infrastructure node, like logging, monitoring, registry, all of this can be offloaded to infrastructure node. One thing to note here is that infrastructure node cannot be used to run your application. It is just the extension of your controllers. So it just offloads certain functionalities. So in your main data center, you have three master nodes, three worker nodes, and you have a regional data centers or your branch office where you have limited resources. You can run OpenShift on a compact cluster, three node compact cluster, where your the controller and worker node profiles are merged into three nodes. So you can run that as a compact cluster as well. And if you have a remote office where you have further restrictions on the resources, you can run it on a single node as well. It's called single node OpenShift. And you have a farther edge, like a PLC kind of environment, or your mine sites, etc. Like for an example, you can use Red Hat Device Edge, which has offering called Microshift, which is again a scaled down version of OpenShift, which is available on that particular offering. You can deploy it on, for example, 2 GB machines or 2 CPU machines as well. So it can go as low as 2 GB, 2 CPU machines. So as a partner, you have choice and flexibility on where you want to deploy and how you want to deploy it. So I just want to highlight one of the features of OpenShift. The main reason being there is a lot of talks on due to some of the licensing changes in one of the virtualization providers. So customers and partners are asking for alternatives. What are the alternatives available if I want to move my virtual machine to a different platform? With the OpenShift, you have a feature called OpenShift virtualization. So what it allows you to do is you can move your existing virtual machines from your existing provider, for example, VMware, and you can move that to OpenShift platform as it is. So you can move your Windows servers, you can move your Linux servers into OpenShift platform. And we also provide what we call the migration tooling, or the migration toolkit for virtualization tooling, which interacts with your vCenter, and you can select which VMs you want to manage. And then you can just select the VM and select which networks, which storage, etc. And then when you click migrate, it will seamlessly migrate from your existing infrastructure provider to OpenShift virtualization as well. Again, it's a vast subject. So if you are interested to know more about OpenShift virtualization, please reach out to Ingram micro team and they can connect with us so we can come and help you and provide you more info regarding OpenShift virtualization. When it comes to customers, there are customers across different industry verticals, just defense, government, education, retail, manufacturing, FSI, to name a few. Again, these customers are using OpenShift in different ways. So some of them are deploying it solely on-prem. Some of them are deploying on a hybrid scenario. Some of them are doing it in a multi-cloud scenario as well. So lot of ways how partners and customers are using OpenShift, and even hyperscalers, they are our partners. They are offering OpenShift as a service, as I mentioned earlier, managed service for their customers as well. So bringing back all together, so OpenShift provides that consistent platform across multiple infrastructure footprints. And whether it is your traditional apps or virtual machines, whether it's your cloud native apps or even advanced applications like if you are using AI/MLs or serverless functions, all of these can be deployed on OpenShift. And it for your developers and operations team, it's the same experience everywhere. So with OpenShift, we provide they can build, deploy, and manage and scale applications anywhere. With that, I'll take a pause and I'm happy to answer any questions. If not, I'll hand over to Matt to give you more detailed insights on how OpenShift is deployed on Dell hardwares.
If guys have any questions, please put it in the chat so that we can answer them. Also, I will take over from Anish.
Yeah.
Looks like someone is typing.
Yeah, I'll try to answer the chat, Matt.
Okay, cool. I'll take over then. Let me share my screen. All right. Thank you, Anish, for doing an awesome presentation on sharing what OpenShift is and natural progression, especially for us at Dell Technologies to work with Red Hat, especially for OpenShift, because OpenShift actually holds a 48% market share. Anish, is that correct? 48% market share for all cloud native
Yes.
Kubernetes solutions?
Yes.
Yeah, so it's only natural that we work with them. All right. My name is Matt. I'm actually from the global engineering team. I'm not part of sales at all, so I'm mainly technical. So if any questions in terms of technical technologies, in terms of how we actually build, how we actually work with Red Hat, specifically around the ACP or Apex Cloud Platform, I'm the guy that you can go to. All right. Dell and Red Hat has been together for a really long time. So ever since they started back in 1999, where they shipped their first Linux solution, it was actually shipped on Dell equipment. Dell saw huge potential in Red Hat, and we invested quite a fair bit of money, close to 100 million in 2005. And it had a natural progression as and when they created new solutions for the enterprise customers, from their RHEL, from their middleware, to their OpenShift, their cloud forms, and all that. We were there with them all along throughout that journey to deploy their solutions on Dell infrastructure. And it's a good thing to know that there are more Red Hat solutions on Dell infrastructure than any other infrastructure. So if you look at it from an OpenShift perspective, how do customers deploy OpenShift today? So we got to look at it from how it started. First off, when Kubernetes won the war, meaning that we decided that we will use Kubernetes from a cloud native perspective to manage cloud native. Customers were then exploring how they wanted to deploy it for enterprise use. And they were looking at Red Hat OpenShift. And the deployment option at the time was to deploy in the public cloud. It made sense then because OpenShift was a new technology, people were still learning, and the fastest and easiest way was to deploy in a public cloud. It may not be the most cost effective, but it was the easiest and fastest way. Once customers tested and tried it, they wanted to increase their cloud native environment, and they also had virtualized environments in their own data centers. So a lot of customers already had VMware and other virtualized environments within their data centers, and they naturally progressed to moving from the public cloud to virtualized environments within their data centers. So Red Hat today works really closely with VMware, and you can actually deploy a Red Hat OpenShift environment in any ESX environment pretty quickly and get it up and running. And that was also a phase where customers were testing out to see how they would actually use cloud native applications, and they were going on a small scale. Fast forward now to 2024, we see a lot of customers now going full into the cloud native world, and they are building thousands and thousands of containerized applications and running that to a point where there's actually more VMs than there are more container applications than VMs within their data centers. And that's where we start to see a shift into the bare metal itself. So this is a natural progression for customers, because now that they are running more container workloads, especially on OpenShift, it makes more sense to actually run those workloads in a bare metal, because that will give you the best performance, best control from a security, from a management perspective, and from a lifecycle perspective. And that's where we start to see that shift. And from a Dell perspective, we are working very closely with Red Hat OpenShift to provide all the solutions across their environments on how customers deploy it today. So what are the integrations that Dell work with OpenShift or Red Hat? So some of the few integrations, or rather we have 4 integrations. The 3 that you see right here now is first off the container storage integration, which is called the CSI. And then we have the container storage module, which is CSM. And then we also added our data protection stuff as well. We also work very closely with Red Hat because Red Hat uses Ansible to deploy a lot of their environments and to automate a lot of their OpenShift. We work closely to add those Ansible modules in there as well. So if you look at it from a CSI perspective, what is CSI? So CSI basically is the single Kubernetes operator that will allow Kubernetes to talk to storages. So in this case, where if you look at all the different storages that we have within Dell Technologies, we have the PowerMax, we have the PowerStore, we have the PowerScale, PowerFlex, and Unity in there. So regardless of what storage you pick, whether it's based on cost, whether it's based on performance, whether it's based on hybrid, where you have the ability to do both block and file, we have that CSI plugin in there, so that the Kubernetes within the OpenShift itself knows how to talk to the storage. Look at the CSI plugin like a driver. The ability to see the storage, ability to assign the volumes to the Kubernetes, and when you deploy the applications, how then does it use the storage in there? But the CSI plugin is a very basic plugin, meaning to say that you can only see the storage and you can only have very few controls. And that's where we built CSM, the storage container modules, to add the features and functions that comes from the storage to the CSI. So in order to access the CSM, it goes through the CSI, and it takes the functions of the storage features and functions like the snapshots, the volume placements. How then do you enable things like resiliency? How then do you check observability, like what's happening within the storage? What kind of performance am I getting? Trending reports and all that. And what happens if you're running an application that is mission critical and you need data replication? With CSM now, you can then enable and say, hey, this particular storage for this application is mission critical. Let's do a data replication for that. And all this is managed through high-end securities via through authorization. So you can do like SSOs, you can do like IDMs and all to manage users and controls for different people within your organization. Dell Technologies, together with XEMC, we are not new to backing up data. So we have been backing up data for virtual machines, for infrastructure, for our databases, applications, and all that for a really long time. So it only makes sense then now that we also support Kubernetes. And this is not new. We've been supporting Kubernetes ever since the injection, or rather the standardization of Kubernetes for cloud native. So now you can use that same familiar backup protection as you would for your other applications, including virtual machines and bare metal servers, for Kubernetes as well. So then this will give you a centralized operation to actually not only back up your other machines, but also your cloud native environment as well. And the last but not least, the last integration that we can talk to, obviously these are not the only four. There are a lot more integrations in there, but these are the four main common pillars of integration. Is our contribution to support the Ansible as well. So Red Hat uses Ansible for quite a fair bit of their automation. And if you are already a user of Ansible and you want to automate the infrastructure that is used for Red Hat solutions, including the OpenShift, you can go to the Red Hat Hybrid Cloud Console. Under Partners, you can actually pull down the Dell Ansible modules from there. So in this case, you can actually pick modules for, let's say, our Dell Open Manage, for example. Dell Open Manage manages our servers in terms of how we power on, how we configure our components and all. You can use that. You can use Ansible as part of the script to actually manage and from a deployment and from a management perspective. So let's now look at it from a portfolio perspective. As partners, you'll be wondering, how then do I deploy OpenShift and what the options available? So in this case, we have the good old traditional three-tier infrastructure. So customers who like building three-tiers architectures, who like block storage, as in a proper sandbox with fiber channel and all that, you'll be surprised we still have a lot of customers who prefer this solution. Especially if you talk to like our Japanese customers, a lot of them I talk to all prefer traditional three-tier infrastructure. However, this is more towards a DIY way of doing things, meaning that you need to have knowledge in terms of how to build that infrastructure, how to deploy OpenShift in there. We then have our software-defined infrastructure. This also leaning a little bit more to our DIY. Software-defined means that we take storage and we virtualize it. So HCI is not new. It's been around for a really long time, made famous obviously by Nutanix and vSAN. But we also have this crown jewel that we have within Dell called PowerFlex itself. And it's actually the most powerful HCI storage in the whole entire world today. All right, don't take my word for it. Go search it up, see what that technology is. You'll be amazed how powerful a PowerFlex is today. And that's where we provide customers the ability to say, hey, I want to do virtualize. Since storage, I want to use x86 servers. I want to use x86 servers as storage for my OpenShift. And that's where we have the software-defined infrastructure in there. Then last but not least, we made it simple for everyone, including partners like you and customers, by making it into an integrated appliance. And so we called this appliance Apex Cloud Platform. And this is the first and only OpenShift appliance in the world today. I'll give a lot more details in terms of what this solution is, so that you can decide which of the three portfolio solutions or the three pillars that you can actually pick from to deploy it for yourself or for your customers. So let's look at it. Let's look from the left to right? So in this case, the good old traditional way itself, the three-tier architecture. For that, does it mean that you have to go and figure out everything? The answer is no. This is what we call our Dell validated designs, and this is something that we work very closely with Red Hat, especially the OpenShift team, in terms of how to design and architect the solution. So together with Red Hat, we have provided white papers, reference architectures, design guides, implementation guides, validated bombs, and so on. If you go and do a search, you'll be able to find a lot of information in terms of how we actually design and build an OpenShift solution based on a three-tier architecture. So in this case, it will come typically with a x86 server running either Intel or AMD, and then you have a choice of storage that you want to use. So in this case, it's typically a block storage, and then you deploy the OpenShift in there. So based on the architecture designs, the white papers, the brown papers, the reference architectures and all, they will actually tell you how we would deploy an OpenShift based on Dell infrastructure. So in this case, it can be a 1 node, it can be a 3 node, it can be a 6 node architecture, depending on how you want to look at it. So let's More importantly, for 3-tier architecture, this typically falls into our physical persistent storage. So in this case, storages that are built based on hardware, specific hardware for storage itself. In this case, customers like you have a choice of whether you want to use block, file, or hybrid of both. So in this case, if you need the most powerful storage, obviously the most expensive as well, we have our Dell PowerMax. And if you need a file that has huge scalability in terms of capacity, but also provide performance for file, then we have our power scale. For customers who want the in-between, something that is cost-effective, can do both block and file, then they will consider things like the power store. So most of the time from a 3-tier architecture, it comes down to customers' preference in terms of what kind of storage they like, and more importantly, the cost as well. So we see a lot of customers who actually build a 3-tier architecture based on a Dell power store. And obviously, like we talked about with the CSI and the CSM, all the 3 storage solutions that you see here will fit in very well for an OpenShift environment. We then have the better software-defined way. So in this case, this is x86 servers being converted into storage itself. So this replaces things like your SAN storage. So in this case, we have our Dell validated platform. So if you see the word platform at the back, DVP, the P stands for platform. This really means that it's a HCI storage, right? Hyper-converged infrastructure storage itself. And this is really for scale, performance, and resiliency. And it's the most powerful HCI storage in the world today, all right? And we have white papers, reference architectures as well, to guide you in terms of how best to design, how best to deploy, how best to run the environment. So to give you an idea, this is actually based on the PowerFlex itself. Why do we say this is actually the most powerful? So unlike different storages, this runs on x86. It's a software base which actually converts the x86 into a storage. Unlike other storages where you have different disk groups, where you have like a RAID 1 where you do 2 disks, a RAID 5 you have 3 or more disks, and RAID 6 and all that. So all this, no matter how many disks you have within a cluster itself, they all have certain groups itself, different disk groups itself. So what this means is that no matter how many disks you add into the cluster, you typically won't increase the performance in there. Reason why is because it's all stuck within a disk group itself. In the group of RAID 1, in the group RAID 5, whether it's a bunch of physical disks, even if 100 disks is only grouped to like 5 disks or 6 disks and so on. With PowerFlex, it works slightly differently. What happens here is that all 100 disks within a cluster will work together as one. So you no longer have the concept of doing a RAID 1, a RAID 5 and all that. We don't have that anymore. So as and when you create, you add this to the cluster itself, it all groups as one. And then when you assign a volume, the volume will create based on all the disks within the cluster itself. So what this means is that if your 100 disks gives you 1,000,000 IOPS, your applications, the volume that you create and assign to your application will have 1,000,000 IOPS. As and when you need to increase the performance, let's say, hey, tomorrow I need 2,000,000 IOPS, I need to add 100 more disks in there. You can just add 100 disks automatically. From 1,000,000 IOPS to 2,000,000 IOPS will be assigned to the application itself. You don't have to do anything, and that's where you have a very linear growth in there. What nice about it is how it actually rebuilds as well, because since they're all contributing to one another, the rebuild is really fast. So if you have 128 node cluster, which is really large, and each node has 18 terabytes, touch wood, one node fail, that 18 terabyte will only take 2 minutes to actually do a rebuild, right? So that's super fast. There's no way you can even copy 18 terabytes into a thumb drive. That's how fast a rebuild within a PowerFlex is. So based on this slide, you can actually see what the design will look like. So a typical OpenShift design on a DVP platform will have 3 master nodes and worker nodes. We call this the hybrid nodes because each node will then act as both a master node and also a worker node. The master node typically is where the management tools sit. The worker nodes is where your applications actually sit and run on. So in this case, customers who say, hey, they want it separated, yes, we can also do it separated, where and OpenShift doesn't charge you to run master nodes. So in this case, you will need 3 master nodes and minimum of 2 worker nodes in there. So in this case, in this diagram, you can see there are 3 compute nodes, which are hybrid, master and workers. If you need to do a separation for security reasons or whatever reasons you have, then we can also separate it, which is 3 masters and 2 worker nodes. The minimum base storage that is required to start is basically 4 nodes, and that's where we'll start with 4 nodes because that's what's required from a redundancy or resiliency perspective, a design perspective. So the base minimum to start a DVP would be to start with a minimum of 7 nodes. And if you need to do a separation or worker node, you need to do a separation of the master nodes, then you will need to start off with 9 compute nodes in there. All right, and this is the choice for most customers who are looking at virtualizing the storage, because PowerFlex can meet any kind of requirements. If you need high-end databases, you can even design your PowerFlex to be more powerful than our PowerMax. Right? That is we have one banking customer that actually does that. All right, they have so many PowerFlex within their clusters itself. It actually runs more powerful than their PowerMax. And this is the next one is the last solution, which is the best co-engineered way. So for the last 2 years, Dell together with Red Hat actually built the first OpenShift appliance. And this OpenShift appliance is what we call the Dell Apex Cloud Platform. In short, acronym, we'll call it ACP for Red Hat OpenShift. All right. This is something my team, based on 300 engineers, actually work on to design and build together with Red Hat. We have white papers, we have reference architectures, but I'm going to show you how simple it is that it will make your life so much easier from a design perspective, a deployment perspective, and management perspective, not only for you, but also for your customers. All right. So what is ACP for OpenShift? Basically, it's a OpenShift appliance that uses what we call common building blocks. So you can see here below the Red Hat logo that there's a word called common building blocks, and it's made up of 3 common building blocks, 2 softwares and 1 hardware. So the first software is the Apex Cloud Platform Foundation software. This does the deployment, the management, and the lifecycle management of the system itself. On the right-hand side, you can see there's the Dell SDS, and this is basically the storage component that is based on PowerFlex. And all this obviously need to sit on some form of infrastructure. You cannot run on air, right? And this actually sits on a next generation Power Edge. When we say common building blocks, this basically are specialized Power Edge servers to actually run the cloud platform for OpenShift. So what does it do? It accelerates time to value, meaning that it's from a deployment perspective, we actually speed it up really fast. So we work with Red Hat in terms of how we then automate that whole entire process. If you ask a Red Hat engineer today from Red Hat to deploy an OpenShift, they will tell you it will take it's basically a 4 days task to bring up the OpenShift before they configure all the other optional operators and all. I can tell you we can do it in 6 hours. So we work very closely with Red Hat to actually automate the whole entire process to bring it down to 6 hours. And you don't even need to use Ansible. So in the case where if you were to deploy it on your own without this appliance, you would take typically 4 days using Ansible to automate the whole entire process. And you get it up and running before you actually configure the rest. We make it in 6 hours. We also provide the lifecycle automation as well. So as and when Red Hat comes up with a new update, upgrade, or even a hot fix, what's going to happen here is that we actually take their hot fix, we test it for 21 to 24,000 hours in the back end together with our BIOS and drivers across our system itself, and then we provide it as a single package update. So as and when there's a need update, you don't have to worry and say, hey, if I update this, oh shit, will something break? All right, will my BIOS, my firmware all be messed up, and I wouldn't be able to access my applications. I mean, take for example, McDonald's went down for 4 hours, right, globally, because of doing an update. Imagine that can actually happen to you. Right, you lose billions of dollars within that 4 hours. So with that testing by us, we take full responsibility to make sure everything works, not only from a Red Hat update perspective, but also from an infrastructure update as well. We also built in things like node image management, where in the case, hey, I want to re-image it, how fast can I do it? So you say, hey, my boss asked me to, we use this OpenShift solution for this particular project. Now I need to change it for another project. Do I need to call Dell services, or do I need to engage partners to do the upgrade, or rather the imaging, or how long does it actually take? For customers who are gung-ho enough and want to do it on their own, which is very unlikely for APJ customers, they actually have the ability to do that. But you as a partner, it makes it even easier and say, hey, oh, you want to re-image? Fine, I'll just take 2 hours to re-image the node, another 6 hours to deploy it. One day job. I get it all up and running. So it's that simple. We also built in the support and integration within the system itself. So anything goes wrong, we can just chat with our tech support and create a service ticket with us. All right. So this is actually based on a 2-layer architecture, same as the DVP. So we have 4 nodes for compute, and this will actually run the RHEL Core OS together with our storage data client itself. The data storage client is basically the ability to talk to the PowerFlex. With that, we will actually install both the controller node and worker nodes. So this one, for this solution, we need to start a minimum of 4 nodes, and then of which 3 nodes will be master nodes, hybrid together with worker nodes. So after this solution is deployed from a compute perspective, you have 3 master nodes and 4 worker nodes. All right. And then once that is up and running, we will then deploy all the OpenShift components in there. You need 4 nodes for storage itself, and then we will install the PowerFlex components. So all in all, these solutions will require a 8-node and to deploy this environment. 4 for compute, 4 for storage, and it actually runs on OpenShift version 4 together with all our PowerFlex software itself. All right. If you buy the common platform environment, which is what we call the MC nodes, you need to start with 8 nodes. And this basically allows us to deploy, to use the same wizard deployment tool to deploy both the storage and the OpenShift compute nodes in there. We may have customers who say, hey, I already have PowerFlex in my environment. Can I use that? The answer is yes. You just have to buy that 4 compute nodes and then deploy that and point back to the PowerFlex manager that you have in your current data center itself. The only difference here is that you will be managed separately. So meaning to say, hey, because PowerFlex is also your existing PowerFlex is also used for other solutions. So your management tool will also be separate. The key difference here is that if you buy a full system, including the PowerFlex for ACP, we will have the integration all in one. So what this means is that if you need to control your PowerFlex, everything is through the CSM within the OpenShift module itself.
Matt, there is one
Yes.
question in the chat. So
Yes.
Is the 8-node cluster a minimum config, or can we build with just 4 compute nodes and make use of local storage from them?
The base minimum is actually 8 nodes if you do not have a PowerFlex. So in this case, if you don't have a PowerFlex, you need to start with a minimum of 8 nodes, 4 for compute and 4 for storage. If you already have a PowerFlex in your environment and you are willing to craft out a volume to assign it to the ACP, you just need a minimum of 4 compute nodes, and obviously the storage will come from the PowerFlex. In this solution, we will only support PowerFlex for now. All right, there's nothing in the roadmap for us to support our physical storage because of the way we deploy and the way we manage and the way we provide lifecycle management. All right, I'm just going to look at the time. Now it's 11:30. I think we have another half an hour. Is that correct?
Yes. So
okay, cool. Yeah. I thought I just ran out of time. I was panicking a bit. Thank goodness we still have half an hour. All right. So yeah, the minimum is 8 nodes, and we don't have any plans to actually support any other storages as of now itself. The reason why is because of the automation bits, the lifecycle management bits, which is very difficult to make. So just to give you an idea, this took us, meaning Dell together with Red Hat, 2 years to actually launch this solution itself. So to add any other stuff in there will take a lot of time. All right. So the automation bits will actually reduce the time to deploy. This makes it a lot faster from a deployment perspective. So Red Hat guys will take 4 days. Even I don't have, I don't work for Red Hat. And I do have OpenShift knowledge, including Ansible, and it won't take me 4 days. It'll probably take me 8 days to actually deploy. Anish will probably take 4 days. I will take double the time. But anyway, we make it so simple to actually deploy this. Let me just show you now how easy and how fast is it to deploy an OpenShift environment. So your customer say, hey, I need to do a POC. How long can you get it up and running for me within a day? You can actually say, yes, I can get it up and running for even a POC or a deployment within the day itself. So let's show a quick video of how that deployment will actually look like. So we will now assume that we actually have the equipment already rack mounted and connected. So we'll power on. What's going to happen here is going to see an end user license agreement, right? Obviously you have to read through and then you click accept. Then from there, you check your prerequisites. Don't quickly run through this. Make sure you read through all the prerequisites. Make sure it's all there. You'll see that the 4 compute nodes are being deployed. In this case, we will assume that we have already deployed the PowerFlex in there as well. So you will also use this tool to deploy the PowerFlex, but it's not part of this demo itself. You can see everything is wizard-based here. So I ask you everything from compute name, IP addresses, what is your SSH security key that you actually be using, all right? So you can choose to manually fill in the information, or you can choose to do an autocomplete. So in the case where you have more nodes than you can deploy, rather than keying the information one after the other, we will key in one at a time. So I'm just going to pause here. You can actually see that out of the 4 nodes here, you can see there's 1 worker node, and then there's control plane, control plane, control plane. So the control plane is basically the master node in here. So these 3 nodes that you see at the bottom here, these 3 nodes are what we call the hybrid node. They'll be both the master and the worker node, all right? So after it's deployed, you're going to have 3 master nodes and 4 worker nodes within the environment. You can key in rack information. So this doesn't change anything. This is just to input within your environment. So when you create a JSON file or report later on, it will tell you where that node is within the rack itself. So all this will require 4 times 25 gig network. So in this case, this is where you create that IP addresses for those network. 2 is actually used for management, and 2 is actually used for the storage connectivity. So in this case, because we've already deployed the PowerFlex, we are connecting to the PowerFlex in there. So like I said, if you bought the ACP storage that comes part of the OpenShift, we will use the same tools to actually deploy this. So once you get this, once you click start, everything is fully automated. You can go have your lunch, come back, or you can, if you like to watch paint dry, have a cup of coffee, and it will actually tell you the progress. Touch wood, if anything goes wrong, it will actually tell you where that installation actually failed. You can actually then fix that point and then restart that installation. So that makes it a lot easier. In this case, you don't have to figure out, hey, if something goes wrong, what actually went wrong. We actually we put it in English, what went wrong and how to actually fix it in there. So once it's installed already, you can actually see it's up and running. So we are actually very conservative when we say 6 hours. In our own lab itself, it takes about 3 to 4 hours only. So if you get everything up and running, if I need to re-image and reset it up based on a 4-node environment, for me and my engineers, we typically take about 3 to 4 hours only, really fast. All right, and from here, you can actually see from a screenshot perspective, everything is a plug-in into the Apex Cloud platform, or rather, Apex Cloud platform is a plug-in into the OpenShift console itself. So you never need to shift out of the OpenShift. You don't have an external management tool for you to manage other than your storage. And if you need to manage your storage, actually here you can see a PowerFlex Manager click plugin. All right, if you have the PowerFlex that comes together as part of the ACP solution, you will not have this. Link and launch button anymore. The controller storage will be built into this plugin, and you can control your storage everything from the OpenShift itself.
And there is a question in the chat as
yeah.
well. So The question is whom to reach out for support in the integrated approach, Dell or Red Hat. Is that support streamlined?
The reach out will be to Dell themselves, to Dell first, and we actually co-engineered this solution together with Red Hat. So we actually have dedicated Red Hat engineers that is attached to this project. So in this case, if you have any queries, questions, or support issues, it will be to contact Dell first, because the Red Hat engineers actually attached to us, not the other way around. Right? Makes sense. So day one deployment. So what does it look like to you as a partner itself? We'll install the MC nodes. We'll install the Red Hat core components in there. So the OpenShift will be deployed. The CSI drivers will be deployed. The ACP management software and web console add-in will be deployed. The operator hub configured and the service mesh configured. Take note, this is where we actually stop. We will deploy up to the service mesh itself. The virtualization operator is not installed by default. So Anish mentioned earlier on that based on certain scenarios, customers will now want to shift their virtual VMs from their environment into the OpenShift environment. So this is where VMs and containers coexist within the OpenShift itself. But by default, the virtualization operator is not installed, and this is where either you can install it for your customers, or customers can install it on their own. So I want to be very clear in terms of where we actually stop and where the partners come in to actually value add to the customers itself, and more importantly, what we do and what you will do moving forward. So Anish showed this slide where we will have the Red Hat OpenShift licenses. OpenShift has 3 types of licenses: the Kubernetes engine, the container platform, and the OpenShift Platform Plus (OPP). For the appliance-based solution based on ACP, the only license that is supported today is the Red Hat OpenShift Platform Plus, the highest OPP. All right, you cannot buy the ACP solution with any other lower licensing. It only comes with OPP. It comes with all the features and functions that OPP bring, except for one. So we don't provide the ODF, so meaning to say that we don't support the Ceph. So in this case, the reason why we don't support Ceph is because we have our PowerFlex attached to it. So you get everything except the ODF itself. Where we will stop deploying up to the service mesh. So if you can see here, under the Red Hat OpenShift container platform, we have the platform services, the application services, and all that. We have the service mesh for the platform services. So this is where we will actually stop. Any other operators that you want to install, anything else you want to use, whether it's for AI ML, for data services, where you want to install the OpenShift AI, also known as roads in the past, all these are additional stuff we will do. So what happens here is that the ACP will bring up the deployment only up to the service mesh. Partners like yourself or even customers will then need to deploy the other components in there. This is where your value add is. Okay. Any questions, Anish, online? Can you just help me check?
No.
Okay, cool. Then I'll move on. Got about 20 more minutes. So from a day 2 operations perspective, let's look at it from an efficiency perspective. So all this is now plugged into the OpenShift technology. So no separate management tools unless you're using your own PowerFlex. Then you have a link and launch, meaning to say we'll provide a link for you to click to go to your PowerFlex to configure the volumes and all, where the CSI, CSM will talk to the storage. But if you bought the storage for ACP, everything will be plugged into the console itself. So if that's the case, you control your storage through the OpenShift console. So no external tools. Everything is managed through the OpenShift console. If you need to check the versions that you're running, so in this case, the Apex Cloud Platform, you can actually go to the Apex Cloud Platform toolbar and then on the left, and then click on the version itself. That will tell you the version that is currently running. All right. Then you can also see the status of your environment, including your infrastructure. Obviously, we'll show you the front view and the back view of the systems. This shows empty because we don't have any disk running in there. So the compute nodes by default actually don't have any disk because we actually run it off the boss card. So in this case, we will support using object store in the future, where you can actually add this into the compute nodes and configure object storage within the compute nodes itself. So it will do a dual purpose. It will support both master nodes, worker nodes for the OpenShift, and also act as a storage node for your object store as well. That will come in the next update, probably sometime around the July timeframe. All right. You can also see the back view of the system. So in this case, if you have different NIC cards or you have additional PCI cards or you have NVIDIA cards in there, they'll actually tell you what components you have in there. And if something goes wrong, whether there's a failure with the BOS card or the power supplies or any of the components like the NIC cards, it will actually tell you as well by showing your X sign in there. If there's any updates available, what's going to happen here is that we will provide those updates through the update button here. So in this case, because this screen capture was captured during the first release, so there was no updates available. But if there's a new update, there will be updates available, and then you'll click download. Once you download it already, you can then click update. Before you click update, they will actually do a pre-check of the environment to make sure everything is okay. So if something is wrong, let's say if you have a hard drive failure, they'll tell you, hey, fix that hard drive failure first before you do the update. You will then, based on the pre-check, you also tell you approximately how long it actually take to do the update. And each update will consist of not only the OpenShift updates, but also the infrastructure as well that has been tested by the engineers for more than 21,000 hours. Let's look at what the updates would actually look like. The updates internally within Dell, we call this the continuously validated state. Those who are very familiar with our VMware VxRail for vSAN, is the exact same name. The design, the idea, the technology on how we actually built the solution is actually based on our experience running our successful VxRail. And we see this as the next successor to the container platform world. All right. So if you already know VxRail, it's the same exact concept. We call this what we call the baseline, also known as the good known state. This baseline will then consist of the Red Hat OpenShift components. So in this case, OpenShift, let's say, for example, 4.13.12. That is what Red Hat releases. And based on that, we have our Cloud Platform Manager that supports this version, including our OpenShift integrations. So things like our CSM, CSI, and all the other components. And based on this, we've actually tested the BIOS firmware and drivers. In this case, BIOS 2.45, and all the different firmwares for all the other physical components. In the case where Red Hat releases a new update, so in this case, let's give an example, 4.14.10, we will then give the baseline a new number called v3.01, for example. All right, this obviously tested for 21,000 hours. And once during the testing, we say, hey, the iDRAC needs to be updated for this particular version. So when you update your environment, you will not only update your OpenShift, your Cloud Platform Manager, your OpenShift integration, but also the iDRAC, because that is a component that is required. You don't want to be updating your environment and say, hey, oh shit, my iDRAC failed. What do I do next? You don't have to worry about that anymore. We test everything and make sure all the components actually work. Once it's updated, upgraded, that will then become the new baseline for the system itself. Every now and then, there will always be hot fixes. All right, something will go wrong, malicious attacks, or they find a loophole. Red Hat will always come in and fix and provide a hot fix for our enterprise customers. So in this case, they provide a hot fix, and we will provide a hot fix based on a 0 day. So meaning to say, as and when they provide that hot fix, we work with them in the back end to make sure everything is okay, and then we provide that hot fix. So if you apply the hot fix, that means that the hot fix, because it's based on the old code, but it only closes certain loopholes for the security's perspective, or to fix a certain component, we make sure that that hotfix is applied, and everything is continue running as per normal. If anything goes wrong, Dell together with Red Hat will take full responsibility for it. Lastly, we'll look at it from a support perspective. So if anything goes wrong, or you need to find documentations on how to do something, this is where we actually built in the support within the Apex Cloud Platform as well. So this is all within the Red Hat console, OpenShift console. So you don't have to shift anything out of the console. If you're going to use OpenShift, everything is controlled through it, including support. If you need to raise an SR, you need to chat with our support, or if support needs to log into your systems to look at something like collect log bundles, or to even fix something that can be done remotely, they will actually log in via through this. All right, and that is all I have for today's session. Just going to check whether they have any questions in the chat.
No
We
new questions. Yeah, please feel free to ask questions, anything related to Dell or Red Hat.
Yeah, to summarize it, Dell has been working with Red Hat for the longest time, 25 years, if I believe, if I count correctly, 1999 to now, that's about 25 years. We've been hand in hand with them throughout this entire journey. More Red Hat solutions run on Dell technologies than any other infrastructure, and we are the first to actually provide the world the first OpenShift appliance, right? That makes it easier to deploy, easy to manage, easy to life cycle as well, right? Obviously, it's the most expensive as well. And if customers like the good old way of doing things, the DVD way, Dell validated design, they're more than happy to do that. If they want to do the Dell validated platform, which is based on the PowerFlex, meaning you build everything your own, you have the skill set to deploy OpenShift, you have good Ansible skills. We have the DVP guide to support that as well. Any questions, anybody? If not, I can give you guys back 11 minutes of your time.
Yeah, I think
Sure.
someone is typing.
Okay, cool.
Questions. Is there anything for the SMB?
This is all for everybody, including the SMBs. So we have the good old version, traditional way of running three-tier architectures. We have based on the DVP, which is based on a platform of PowerFlex, and also the uh, the ACP way of doing that. So you can see that Red Hat's OpenShift is moving into a bare metal environment, right? And that's where customers would steer to when they want to go full in on cloud native. But if your customers are just trying out, they don't know whether they would want to use cloud native, they don't know whether they want to use OpenShift. Most customers in that environment will start off in the public cloud. It's not the cheapest, but it's the easiest and the fastest way to cancel a subscription. So in this case, if I'm going to use it for 2 months, 3 months, I'm just going to test it out and see how that works within my environment. Then most customers would then go the public cloud way. Most of your SMB customers are also VMware customers as well. So a lot of them are already on ESXi today. If they are already on that, they can then deploy OpenShift in those environments. So in this case, it works best on VxRail. So customers will say, hey, I don't know whether I want to go cloud native, or if my environment still has more virtual machines than containers, but I love Red Hat OpenShift. I want to run that because it's going to be like 30% of my workloads within my data center. They would then consider things like running a VxRail, which is based on vSAN in their environment, and then deploy OpenShift as a virtual environment within ESX itself. So it depends on cost and scenarios. But if customers, SMB customers, are full all in into Red Hat OpenShift, the only way is to go bare metal.
Yeah, and from Red Hat perspective, like if you are a Red Hat partner, you will be provided with 500 entitlements of Red Hat products. So as a partner, if you want to try out Red Hat OpenShift or any other Red Hat products, you can do that in your lab environment or your whichever environment you have for like allocated for you. You can use that and start exploring the product as well.
Awesome. Yeah, I have a Red Hat OpenShift in my own home lab.
Yeah.
So yeah. So I'm using, yes, obviously I have a server at home. So yeah, I run ESX I run OpenShift on ESX on a single server at home.
Yeah, yeah. Like again, the single node OpenShift, you can, if you have at least 16 GB RAM, you can run that as on a standalone server. Again, with the device edge, like if you want to explore, you can run it on a 2 GB machine, 2 CPU machine as well. But it is a scaled down version of OpenShift, mainly intended for edge use cases. But yeah, if you want to explore, there are many options. As Matt said, you can run a hybrid node as well, like a 3 node compact cluster with the like hybrid modes, where workers and controller will be merged into one. So you will run 3 node cluster and you can run your workloads on top of that as well. I think that's all the question we had. So yeah.
Shaf, do you have any last words before we close off, or our
Thank you, Matt. Thank you, Anish. It was a great session, and thanks everyone for joining this webinar. I think like I'll just reach out to Ingram Micro, and then we will just allocate the vendors where we need them, and then yeah, we'll just roll these opportunities, and we'll figure out the future opportunities based on this platform. Thank you, everyone.
and thank you Ingram Micro for organizing this. Thank you.
Yeah, likewise. And thanks all for attending as well. Thank you. Cheers.
Thank you.
Cheers, guys. Take care. Bye bye.
Yes, bye.